Hi everyone, good afternoon to all of you. This is Yashwant Kommanapalli from CSC Data Science second semester. Uh, the subject is differential equations and calculus. On this subject, the topic is higher order non-homogeneous equations. So now we are going to the topic. I want to give presentation about it. Next, higher order non-homogeneous equations. First, introduction. Introduction to higher order non-homogeneous equations. Higher order non-homogeneous equations involve derivatives of an order greater than 1. Okay, what is the main meaning? The definition of the higher order non-homogeneous equations is the derivatives which have the order greater than 1. When we derivate that equation, the order can be greater than 1. That equation is known as a higher order non-homogeneous equations. If not, it is homogeneous equations. These equations are typically expressed in the form of given that form. Understanding this equation is critical in various fields, including physics and engineering. Okay, these equations, the non-homogeneous higher order equations is very understanding is very critical in various fields like physics and engineering. When in intermediate level it is very easy to learn, but in this engineering and physics field it is very difficult to learn. Okay, next, here also we have the definition. Non-homogeneous equation definition is the non-homogeneous equations contains a non-zero function on the right hand side. In the RHS side, the non-homogeneous equations contains a non-zero function, and it contrasts homogeneous equations have f of x is equals to 0. In homogeneous absolutely is inverse to the non-homogeneous. The presence of f of x introduces a particular solution that must be found. Next, what is the general form of higher order equations? A higher order differential equation is defined by its order, which is the highest derivative present. The general form can be written as given in the slide, and also coefficients can depend on the independent variable or be constant. Sometimes the coefficients which are depend on the independent variables and are be constants. Sometimes the coefficients will be variables, or the sometimes it will be constant depend on the equation. Solutions to non-homogeneous equations. The solution to a non-homogeneous equation is the sum of the complementary function and a particular solution. What is the solution is to the non-homogeneous is the sum. Sum means the adding of two. Next, now here we are adding complementary function and particular function. Those two particular solution, the function and the solution adding, then we get the solution to the non-homogeneous equations. The complementary function is the solution to associated homogeneous equation. Complementary function is one of the solution to associate homogeneous equation. It is for homogeneous, not non-homogeneous. The particular solution is specifically tailored to the non-homogeneous part, like f of x. Now here we learned that word like complementary function. That's what is complementary function. Complementary function is derived from the characteristic equation. We know that characteristic equation a lambda is equals to I, next equal to 0. Next, the complementary function is derived from the characteristic equation of the homogeneous part. It reflects the behavior of the system without external forcing. Techniques such as the method of undetermined coefficients or the variation of parameters can be used to find it. It is about the complementary function. Next, another word also we are in that meaning, the definition and that particular solution. Next, what is meant by particular solution? A particular solution can be determined by using various methods including undetermined coefficients and variation of parameters. The choice of method depends on the form of non-homogeneous term. The choice of method depends on which non-homogeneous term. In every complementary solution of function, particular solution, every one is depend on the non-homogeneous equation terms only. Next, finding the particular solution is crucial for solving the overall equation. The solving overall solution equation is very good, but the particular solution is very crucial to solve. Method of undetermined coefficients. This method is effective for polynomials, exponentials and trigonometric functions. This method, which non-homogeneous method, is very crucial and effective for the polynomials. You know polynomial, it has to have the powers of equations like monomial, trinomial, binomial as well polynomials. Exponentials, the equations which are in exponential forms, the trigonometric functions. Sometimes the equation in the form of sine, cos, the trigonometric functions. The idea is to guess the form of a particular solution and determine coefficients by substitution. The idea is to get the form of. So when we want to get the form is which is in which form particular solution and determine coefficient by substitution. This method works well when is of a specific standard form. Variation of parameters. Variation of parameters is a more general method for finding particular solution. Variation of parameters is a more general method for finding. Another main method is variation of parameters. It helps to find the particular solution. It involves using the solutions of homogeneous equation to contrast the particular solution. This method can be applied regardless of the form of f of x. Next, here we take one of the example of non-homogeneous equation. Is considered the equation y of x is equal to 3 minus 3y double dash plus 2y equals to e power of x. The complementary function is found by solving the characteristic equation. The above equation also we get the one of the complementary solution. The particular solution can be found by using the method of undetermined coefficients. We use the method which is undetermined coefficients. Applications in physics and engineering. The non-homogeneous higher order equations are prevalent in modeling dynamic systems. In the dynamic system, it is one of the very prevalent. Next, they are used in structural analysis, control systems and vibration analysis. Understanding these equations allows engineers to predict system behavior under various conditions. Understanding these equations allows engineers to predict the system behavior under the various conditions. Next, initial and boundary conditions. Initial condition specifies the value of functions and its derivatives at a given point. Boundary conditions apply to the values of function at the boundaries of domain. Both types of conditions are essential for uniquely determining a solution. The both conditions are essential for the uniquely determined solution. Initial conditions as well as the boundary conditions. The both conditions, initial conditions are derived at a given point. Boundary conditions apply to the values functions at the domain. Is that domain is at a given point. The both are very essential to find the solution. Numerical methods for solution. Numerical methods such as the finite difference method are often used for solving higher order equations. The methods provide approximate solutions when analytical solutions are difficult to obtain. Numerical techniques are particularly useful in complex or real world applications. Numerical techniques are particularly useful in complex or real world applications. Stability and behavior of solutions. The stability of solutions is a crucial aspect of higher order non-homogeneous equations. Analysis of the roots of the characteristic equations helps determine the stability. Understanding the long-term behavior of solutions is important for practical application. Okay. Understanding the long-term behavior of solutions is important for practical applications. Common mistakes. Some members are doing the common mistakes too in the finding of a solution. That are one common mistake is neglecting the complementary solution when determining the overall solution. For the overall solution, the complementary solution is one of the main thing, as I have said already. Another area is displaying the method of undetermined coefficients for non-standard forms of f of x. It is second mistake. Next, properly accounting for initial or boundary conditions essential for accurate solutions. The both initial or boundary, the both are essential for the accurate solutions. So properly account them. Next, summary of key points. Higher order non-homogeneous equations are fundamental topic in differential equations. This is one of the fundamental topic in the differential equations. Next, the complete solution consists of both complementary and particular solutions. This is the second one. Next, various methods exist for solving these solutions, each applicable under different conditions. There are so many methods to solve these equations, each applicable under different conditions. Next, few directions and teachers. Future research may focus on developing more efficient numerical methods for complex equations and investigating the impact and non-linearities in higher order equations is an emerging area. The integration of computational tools with analytical methods will enhance solution strategies. And finally, thank you for giving this a wonderful opportunity to discussing about the higher order non-homogeneous differential equations in the part of differential equations and calculation subject. Thank you.